Okay, hi everybody. My name is Andy Sterling. This is a PowerPoint presentation in personal protective equipment in the construction industry, subpart E, in the 1926 CFR. We're going to move on and from here, but remember today we're going to be talking about PPE in construction. We're also going to mention a little bit, because we've had quite a few questions about COVID-19 and how that affects the actual environment for folks that are working in the construction industry. First thing we want to do is talk a little bit about being able to identify some of the hazards and the PPE that we need to keep up with those hazards while we're on the job site. That means having a basic understanding of the standard, as well as having a good understanding of what the hazards are and what the PPE we're going to use. Essentially, PPE is just a barrier against workplace hazards. Remember, we always want to try to use things like engineering or elimination is best, or maybe even an administrative strategy to eliminate a lot of our hazards before we actually get to PPE. PPE is always our means of last resort. So I always encourage people, look at what you're doing and see, do I really need to do it this way? Can I do it a different way? And if so, maybe you can adapt to that and save yourself some grief. However, if you do find you do need to use PPE, there's a lot of things we have to consider when we're using it. It's not just as easy as slapping on a hat or a pair of goggles, to protect us against whatever the danger is. Remember, PPE is just a temporary measure. It's not designed for permanent use. So we put it on to protect us while we're doing that job, and then after that we might have to remove it or even change PPE depending on a change in the hazard. Personal protective equipment, it's important that we have an education system and a system of training. All right, so we have to establish and supervise programs for education and training of employees and employers. You need to know what the hazards are, how to address the hazards, and the proper PPE to choose when addressing those hazards. PPE for one job site may not be anywhere remotely the same as what it is for a different job site. If you are getting ready to go camping in the desert, your equipment you're going to bring is quite a bit different than if you're going to go camping in, say, Alaska or, somewhere in the frozen tundra. Every single job is different. So even though you might be doing construction, the job site that you're doing it on can change, and those changes can have a dramatic effect on the PPE that you're going to choose. Remember, the employer is always responsible for folks wearing PPE in operations where there's exposures to hazardous conditions. So if your folks are going to be exposed, it's up to you to make sure they're wearing their PPE. So if you're a contractor, make sure that you're going and doing regular inspections. Make sure that your subs are wearing all their PPE and following the rules. One of the biggest things that gets a lot of contractors in trouble is their subs will actually break the rules, and when they do, the contractor gets involved as well, because now it's considered a multi-employer work site. So make sure that you're doing regular inspections and you're doing regular training and making sure that your folks are wearing all their proper PPE. Now, if you've got folks that are going to be using things like poisons, caustics, and hazardous substances, that requires very specific training, okay, because now they're handling dangerous chemicals. So not only are you going to have to do PPE training, but you're also going to have to do some HAZCOM training, because a big part of choosing your PPE comes from reading and understanding safety data sheets or SDS sheets. So make sure that these folks, when you're training them, that they're aware of the hazards, they're aware of the personal hygiene techniques that they need to use, meaning decontamination, washing their hands, and making sure they clean up before they take, say, a smoke break or eat or drink or do anything like that, because a lot of times that's actually how we end up getting the exposure. Is somebody will stop, they'll pull down, say, a mask or pull off a respirator, have a smoke, and then pull it back up, and in the meantime they've gotten exposure through their hands, the gloves they were wearing, they're still wearing while they're smoking a cigarette. So, that's on, gets on the cigarette itself. You end up inhaling it. So you can see how it's just kind of a downhill effect. So make sure that they understand if they're going to take a smoke, have something to eat, whatever they're going to do. If they're working in very hazardous condition or with hazardous chemicals, they need to make sure they get cleaned up before they actually take those breaks or stop for lunch. And the employer needs to instruct each employee in the recognition and avoidance of unsafe conditions. One of the big things that I tell people is you can avoid a lot of hazards just by using common sense. So even though you have PPE, it doesn't make you invulnerable to everything. I see many a person wearing PPE on a job site that is, say, an arborist, and when they stick their hand in that wood chipper, guess what happens? They lose an arm if they're lucky. If they're unlucky, they lose their life. So, just wearing PPE does not make you invulnerable. You also need to use your head and recognize hazards. Make sure when you're wearing your PPE that you're doing regular inspections, and make sure the folks are keeping their PPE clean and well maintained. A pair of dirty safety glasses or safety glasses that are all scratched up are going to impair your vision. When your vision's impaired, you tend to not see nearly as well. Am I right? And so it's important. Make sure your folks are wearing clean PPE, that they're wearing clean safety glasses, and don't have a lot of scratches. If you see a lot of scratches or you see damage, you need to get that PPE replaced and get it replaced right away. Okay? And this is the same is true for hearing protection. Steel toe boots, a lot of times steel toe boots, the leather will get worn out and the steel toe will pop out. A lot of workers will end up wearing something like a sneaker or a work boot or cowboy boots or something that looks like a steel toe boot and it actually isn't. So make sure you're keeping an eye on all of those things and make sure that they're keeping it sanitary and in reliable condition. If an employee owns their equipment, remember the onus falls on the employer to make sure that that equipment is up to snuff when it's on the actual job site itself. So say a worker wants to get those fancy Oakley sunglasses as opposed to, the just cheap $2 pair that you give them to use on the job site, they can do that. However, it's up to you to make sure that it is ANSI approved and it has that actual Z87 stamp. Also, PPE needs to be designed for the actual job. You can see here, there's a shoe, and that shoe might be fine if you're working in, say, a laboratory or maybe in a warehouse. But it may not be fine for a construction site. In fact, for a construction site, you may want to have something that's a bit more durable, something that comes up above the ankle. Maybe it's all leather, gives your foot a little more protection. Something with, say, a steel shank in case you step on a nail or something sharp. And maybe something, that also has a steel toe. Or maybe a composite toe, which is just as good. It's just lighter, so your feet don't get as tired. If you notice where it says, where we see our fellow that's wearing his fall protection, notice it says not correct, and that's because the rope is actually tied to that D-ring. We do not tie ropes to D-rings for fall protection. We're going to have a lanyard, and that lanyard is going to have deceleration built into it, meaning it's going to tear a certain amount, or in some cases we'll use a retractable that will pay off a certain amount. If you start to fall, it will latch hold just like a seat belt and keep you from falling. So again, it's important to understand how the PPE works and the proper way to use it. The employer needs to pay for the PPE, okay? So it has to be provided by the employer at no cost to the employees. Now, things like everyday clothing, like long sleeve shirts or pants and things like that, normal work boots, those things are exceptions to the rule. But things like hard hats, safety glasses, that kind of PPE, that needs to be made available to the employee. Make sure whenever you train, I always tell people, if it's not on paper, then it's vapor. And what does that mean? Well, essentially, you may be the most honest person in the world, and you may claim up and down that yes, 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 we did our training, we did our training, we did our training. And that's fine, but it doesn't really mean anything unless you document your training. So make sure whenever you're doing safety training, you document it. It doesn't have to be fancy. It doesn't have to be elaborate. It doesn't have to be a Microsoft spreadsheet or anything else. It can be as simple as just a sheet of notebook paper with the training, the date, the instructor, and then a list of all the people that were in it, the topic that was covered, and just have a list of everybody's name and have them sign it. And that's all. It's very important to make sure that you document your training. Always document your training, period. Okay? Now, some construction standards require additional documentation or certification of PPE. That includes things like HAZWOPER, right? Hazardous waste operations goes a little bit further, a little bit above and beyond. Fall protection, confined space, right? So some of your health hazards, SEPs, and those can be found in Subpart D and Subpart Z, toxic and hazardous substances. So it's important to remember that sometimes there are very specific things that you need to document in addition to just general documentation of training. And some of our basic hazard categories that we fall back on when we're looking at PPE and doing job assessments to determine what the PPE we need, we see here, is it a fall danger? Is there excessive heat? Is there electrical arc? Is that a danger? Is electrical shock a danger? Is there chemical exposure? Could you be compressed by something, right? Could you be hit by something? Is there an impact danger? Is there excessive motion? Extremes in temperatures, extremes in elevation, maybe sharp objects or rolling objects. If we have large pieces of drain tile, there's drain tile out there that I can remember, as a boy, seeing very, very large pieces of drain tile that were much taller than me, and we would skate in those, right? We ride our skateboards through them and do all kinds of tricks. Again, if one of those starts to roll, it can roll right over you and you can get hurt very badly. So it's very important to remember, take a look at everything on that job site and don't assume that any of those things are absolutely fine. You need to make sure you check them out. If you got, say, something like big drain tile, make sure that it's chalk so it doesn't just happen to roll. So a lot of different, very specific PPE, and one that's very specific is electrical protection. Remember, electricians are subjected to different voltages and amperages, and electricity can definitely kill because it's always looking for ground. And we're mostly made of water, so that makes us an excellent conductor. So remember, if you have electricity and electricity jumps, it's going to use you as a possible conductor trying to get to ground. The best way to protect yourself is by insulating yourself. And you can see here examples of rubber insulating blankets, mats, covers, line hoses, gloves. You can see our workers here, they have on special shoe covers, they have on special gloves. Even their hard hats are especially designed for electrical work. Now, when we have specific design requirements for electrical PPE, and those are listed in Table 4E. And you can see here where these fellows are doing some work, this transformer, and they have special glove and arm protection for reaching their arms in there. So those gloves are insulated, and that's going to protect them from an electric shock. A lot of employees will work in areas where they could get an impact in the head, right? Something that is a flying object, something that's a falling object that could hit them. And for that, we actually have very specific head protection. And you'll see that head protection, some of these are actually designed for electricity, and they're going to protect us from electrical shocks and burns. Some are just regular, ordinary hard hats. But it's important to remember, regardless of the hard hat, that you need to make sure that you check for that American National Standards Institute number, right? ANSI. We see ANSI numbers on everything. Probably the most popular is ANSI Z87, which is for eyeglasses. In this case, for a hard hat, we're looking for ANSI Z89. And you can see there's a couple of different ones there. There's a 2009, 2003, and 1997. Anytime they make a change in the standard or update it, they're going to put that new date on there. But remember, helmets are designed to protect against falling objects and flying objects, and our hard hats that we wear, it's important to make sure it really is a hard hat that's designed for that job and has that ANSI number, because there's a lot of times folks will have things like bump caps and all. They're not nearly as good, right? Or wearing a batting helmet. That's just not designed. A batting helmet is designed for, a baseball that's being pitched at a certain speed. It's not designed for, say, a nail, okay? Or, some sort of heavy flying object that's coming towards you. So remember, look for that Z89. Hearing protection is another big one. And when we refer to 29 CFR 1926, permissible noise exposure, we're going to see how we actually protect our hearing. Now, everybody wears earplugs and everybody's seen a lot of different types of earplugs. Remember, earplugs are designed in a lot of different shapes and sizes, and that's because the wearers like them a lot of different ways. You have everything from the very, very cheap little foam beer cans to the actual silicone units like you see here. These actual silicone earplugs that you see here, they actually have little buds, which you can see here and here, that fit in the ear canal. How do we know if we need them? Well, here's a great example. We can use what's called a dosimeter, and a dosimeter is actually going to measure that noise level and see what that noise level is, and that's how you're going to make that determination. Okay? There's a lot of different types of ear protection. I mentioned some of these. Here's the little foam beer cans. Here's the little inserts that go into your ear, the little silicone inserts. And these are fine, and they work great. But remember, everybody has a different preference. So it's good to have a couple of different types that are there on site. I prefer this type. Some people actually prefer these. Some people find these very uncomfortable. Some people prefer these. Again, it's all up to the wearer. So let's make sure that we keep that in mind. We can see this guy here, he has nothing. No ear, no eye, and no face protection. What's he doing? Well, it looks like he's stripping shingles off of a roof. And so, that's bad, because if he falls, or if he takes that crowbar in the face, or if he pops a nail up into his face and gets one caught in his eye, he's going to have a very serious injury. So keep those things in mind. A lot of people will try to put cotton balls in their ears, and cotton balls are not an acceptable protective device. Right? It needs to be an actual unit that is going to reduce that amount of noise that's penetrating your ear canal and getting into your eardrum. Face and eye protection is very important. You can see here we have a great example of welding, and with welding we're going to be using a mask, and that mask is going to protect our vision. Unfortunately, one of the things that we see on TV a lot of times with these custom car building and motorcycle building shows is guys will be wearing their sunglasses and they're doing, just little tack welds and things like that, and they're just they got their face on it and then they kind of turn away real quick and they hit that weld, and that's not good practice at all. Okay, a good safe welder is going to wear welding glasses or a face shield, okay, and they're going to have proper PPE. And you can see this guy, he's got gloves with gauntlets, but he's wearing a short sleeve shirt, so he's exposing himself to UV radiation, which essentially will cause a sunburn. But when it happens over and over and over and over again, the more your skin is exposed and the more burned it gets, the more susceptible it is to things like cancer. With eye and face protection, again, I mentioned about ANSI, right? ANSI is very important. So always look for that ANSI Z87. In this case, it's Z87.1, Occupational, Educational, Personal Eye and Face Protection Devices. So you will see on a pair of glasses, it'll usually be somewhere on the arm, maybe here or just on the inside. It will say ANSI Z87 approved. It will be on the lens, ANSI Z87 approved. It won't interfere with your vision, but you will see it etched into the actual lens itself. Now, sometimes we have folks that wear prescription eyewear. I know I do now. I started wearing glasses, I guess when it's been about 7 years now that I've been wearing glasses all the time. And so when I'm wearing glasses, I really don't need them to see distance, but I do need them to see close up and to read. So if I'm in a plant or I am working on a job site, I either will use a special pair of prescription glasses that are made from safety glass, but they're in my prescription. They also have a built-in face shield so that I can see, or I'll wear my regular glasses, but then wear safety glasses or over the glass safety glasses to protect my eyes and, of course, protect my normal glasses. Now, if I have something like a full face respirator, in that case, that may have specs built into it. So like for my SCBA mask or say a full face respirator, I'm going to wear a spec kit inside of there because if I was to wear my glasses, it wouldn't make a good seal around the mask. So protective safety eyewear has to be reasonably comfortable under working conditions. Otherwise, folks aren't going to wear it. And the whole reason that's there is to provide protection against specific hazards. Remember, if you're wearing, say, a pair of goggles, those work great for things if you are worried about something coming back and hitting your eye. But they're not necessarily the best for things like dust and fumes and liquid splashes. In that case, you may want to wear a pair of goggles. Goggles will give you much, much, much better protection. Or you can, wear goggles and for added protection, even wear something like a face shield. One of the big things is they need to be easily cleanable because you need to be able to see through them. Anytime they're on your face, they're going to get dirt, they're going to get sweat dripped onto them, and when they do, it's going to be really, really hard to see. So you need to be able to clean them, and you also need to be able to disinfect them because, again, we want you to wear safety glasses every single day, and nobody wants to put on a pair of gross safety glasses. So disinfecting them, cleaning them off is important. Sometimes it takes no more than just wiping them down, with a wipe. That works great. Your shoes, make sure that your shoes meet the ANSI Z41.1 safety toe footwear standard. So here we see a pair of construction boots. These are pretty standard wear on job sites. I see a lot of folks that wear a lace-up boot. It doesn't necessarily have to be a lace-up boot. It can be, say, a cowboy-style boot or even a Wellington-style boot that you pull on. These are very, very popular with folks. And so, whatever you do, just always make sure when you pick that out that it's got that ANSI Z41 stamp in it. Now, respiratory protection with this, I want to talk to you a little bit about some of the dangers that we're facing today. Now, if you're working on a job site, there are two big construction hazards that you are primarily worried about when it comes to respiratory protection. The first one is going to be asbestos, but most of your asbestos is out of construction now. And so the only time you're really going to run into it is if you're retrofitting an old building, say a building built before 1980. In some cases, we are going to look at these old buildings and just make the assumption that they have asbestos insulation because a lot of them do, okay? Especially if they're commercial buildings, old buildings downtown, old brick buildings, old factories, things like that. Really not a whole lot of asbestos was used in, say, residential building, except for things like some linoleum floor tiles and things like that. So it's important to remember if you're doing old construction or renovation of an old building, you may run into asbestos. However, everybody out there is going to run into silica. And silica is the new asbestos, right? So with silica, the big thing we worry about with that is silicosis. And silicosis, like I mentioned earlier, is a reduction in our lung capacity. So what happens is you breathe in silica dust, and these dust particles that you actually breathe in are microscopic. So, there's dust, and then, we get a certain amount of dust and silt and sediment that gets caught in, say, our nose hair and mucus, and we sneeze it out, or we'll blow our nose and it'll come out that way. And a lot of that gets, our system is protected by things like nose hair, mucus, cilia. These things protect our breathing passages that get down to our lungs. However, microscopic particles, very tiny particles, can penetrate those and get past those defenses. And once they get down in our lungs, there's no way for them to get back out. And how it works is, if you think about it, that little tiny silica particle almost acts like a piece of sandpaper and irritates what we call alveoli. Alveoli are the little tiny air sacs that make up our lungs. When we think about lungs, we think of them looking like two big kidney bean shaped objects in our body. But really what gives them those shapes is a thin layer. It's a thin sheathing that protects all that alveoli and compresses it. If you were to take that alveoli from your lungs and spread it out, it would be the size of half a tennis court. So that's a lot. That's a lot of volume. Okay? So when you take and you fold all that up, and it's in our lungs, right? Those alveoli, what they do is they transfer gases. So you breathe in air, the air is pulled, or the oxygen is pulled out of the air that you breathe in, and that goes to your lungs. And then waste, or waste gases, are exchanged into the airflow that is going out when you exhale, right? So you breathe in, you breathe out. That's why they say in with the good air, out with the bad. All right? What a respirator does is it filters those particles out, so we're not breathing those particles in. And these particles can be dust, they can be asbestos, they can be all kinds of solid particles. One of those particles that they can be, which is the main thing in the news now, is, say, a virus particle. Now, one thing that I wanted to mention about, say, now we're talking about COVID-19 and coronavirus, and people say, well, what exactly is coronavirus? The virus itself, it's not a living organism, okay? It's a protein molecule. And that protein molecule is covered with a protective layer called a lipid. And that lipid is nothing but a fat. What happens is, when you breathe that in through your nose or through your mouth or whatever, it enters your lungs and it changes the genetic code or causes a mutation and converts those cells into aggressor or multiplier cells. And that's why the virus will spread in your body and will overtake it. Now, it's not a living organism, but will overtake it. Now, it's not a living organism, but it's a protein molecule. So it can't be killed, but it does decay on its own. And that disintegration or that degradation depends on temperature, humidity, and the type of material that it's laying on. Say it's laying on something like fabric, something porous like paper, it might be there for 3 or 4 hours. If it's on cardboard, that might be 24 hours, up to 42 hours on different types of metals, 72 hours on plastics. So again, it depends on what substrate it lands on, okay? So this is the reason why, when you're, they keep talking about in the grocery store, not to handle groceries, or if you're going to handle something, then you need to buy it, right? You put your hands on it, you take it home with you, because your hands have germs, and in this case, your hands also have germs. They have bacteria, they have viruses, they have all kinds of stuff, okay? So that's the reason why we want to be so careful about what we touch and what we pick up. One of the big things too that we hear about is social distancing, keeping that 6 feet between us and another person. In your case, it would be between you and another worker, and that's important because you don't want to breathe on them, you don't want them sneezing on you, A sneeze, you may think, oh, sneeze is not that big a deal. But when a sneeze comes out, it's accelerated. It's going just over 100 miles per hour, and it will project about 6 feet in most cases. You know, a little bit less than 6 feet, and that's why we say 6 feet at a minimum for our social distancing. Remember, one of the things that I mentioned earlier was about hand washing. And that virus, that protein molecule, it's very, very fragile. And all it has is that thin outer layer of fat, that little lipid. That's why if you wash your hands with soap and water and really scrub them for 20 seconds or more, right, and make a big old foam while you're doing it, that dissolves that fat layer, and it will cause that protein molecule to disperse and break down on its own. Okay, so that's why hand washing is so important. Heat also melts it, so if you're using hot water, that definitely helps. Alcohol or a mixture of alcohol that's at least 65% alcohol will dissolve any fat. And that's why, you know, people will say use hand sanitizer, because hand sanitizer has a much greater amount of alcohol. Okay, it's 65% alcohol. You know, you've heard some people like, well, you can use vodka and you can use it. You cannot use vodka. You cannot use any spirits because those things do not have nearly enough alcohol content. All right. Also, you know, our big one is mixing bleach and water. If you've got 1 part bleach, 5 parts water, that's going to dissolve that protein and break it down. So no worries there. So any of your PPE that you were thinking about, well, hey, you know, how do I sanitize this? How do I keep it clean? That 1 part bleach to 5 parts water in a bucket, that's a great way to do it because that's going to kill any of the viruses or bacteria that's on the outside. Now, one of the big things we talk about with this is wearing a respirator. And so you can see here, this is a half mask respirator. It has cartridges, and those cartridges also may have an external filter, and that filter acts as a pre-filter that filters particles out of the air before the air actually goes into those canisters, where those canisters or those cartridges will filter out things like organic vapors, maybe ammonia or something else. So before we wear one of these, we have to have a written program. And that written program is made of several different parts, and those parts are having a medical evaluation, because we want to make sure, since this puts a strain on our breathing, we want to make sure that our breathing, our person that's using these things can actually have that additional strain on their breathing, right? So if you have some warning factors like high blood pressure, or maybe you have COPD, something like that, you might have an issue wearing a respirator. So it's important to make sure that you have that medical evaluation. The other thing is fit testing. If you don't have a proper seal, then you are not going to have a good respirator that's going to seal you from the elements. It's going to give you a false sense of protection, which is not good. You need to have a good seal, and how we determine this is by actually doing fit testing, either quantitative or qualitative fit testing, but one or the other. We want to make sure you make a good seal. This is one reason why when we're using a mask like this one you see here, which is a half mask respirator, this mask actually all the way around here is it forms a seal to your face, and that seal is between your skin and the outside of the mask, and so it conforms to it, and when you breathe in, it seals up, and the only thing it's getting through is those through, or whatever comes in through those cartridges. Okay, and that's the reason why we say it's so important. If you're going to wear a mask like this or an SCBA, you need to be clean shaven, or just make sure that there's no hair between your skin and the mask that's trying to make the seal, right? So if you got a great big long handlebar mustache, you know, that you roll up at the ends, that's fine. Just make sure all of that is crammed into your mask and it's not going between your mask and your skin, interfering with the seal. Make sure you choose the right one, right? Not all masks are the same. One thing that I tell people about is there are different types of masks in this emergency. You've heard so much about N95 respirators, okay, or N95 filtering face piece. And they are quite a bit different from something like a surgical mask. A surgical mask does not form a seal. A surgical mask is designed to keep large droplets from hitting you in the face, but it's not designed to seal and protect your air passages. Training is essential. You've got to make sure your folks know what they're doing and know how to don one of these, how to take it off or how to doff it. And then also keeping up with your program is important. Remember what I said earlier, if it's not on paper, it's vapor. So make sure you keep track of your training and make sure you write down everything and keep track of the person, whether they've had their evaluation, what respirator they have, what size that respirator is, and what that respirator is for. I cannot emphasize that enough. Now, safety belts, lifelines, and lanyards, very important to wear on a job site. All right, we can see our man here. We got a couple of different instances. Our man here, you know, he's got a lifeline, right? And his anchor point's here, but all of this is all slack. So if he falls off this roof, nothing's going to happen because this rope doesn't have enough tension in it to keep him from hitting the ground. Remember, you know, if it's 8 feet between you and the ground and you've got 20 feet of rope, then you're going to fall, hit the ground, and still have 12 feet of rope left up on the roof. These fellas over here, they're not even wearing fall protection. And notice they're just walking here balanced on this 2x4. If they fall, they're going to go straight down. Okay? So again, wear your PPE, and it has to be rated for a minimum dead weight of 5,400 pounds. Now, a lot of people will say, why 5,400 pounds? The reason we say 5,400 pounds is because that's a minimum dead weight, and nobody weighs 5,400 pounds dead weight. But when you fall, the amount of force that you put on that harness and that lifeline is a lot more than your regular weight. So if you weigh 200 pounds, if you fall and you just fall a few feet, when that rope grabs you, that's a lot more than 200 pounds of force. An incredible amount more of 200 pounds of force. Because remember, weight is just a description of force. This is a description of your mass with a force of 9.8 meters per second square exerted on it. And that's because that is gravity. Okay? Whereas if you're measuring force traditionally, you're going to say it's your mass times whatever acceleration is. So it's F equals ma. And that amount of acceleration, obviously if you're falling from a much greater distance, it's a much greater potential energy, meaning you are going to hit a lot harder. So there are different types of safety belts, lifelines, and lanyards. They have to be a minimum of 1/2-inch nylon or equivalent and have a fall of no greater than 6 feet, because all of these nominal braking strengths are designed based on having a free fall of no more than 6 feet. Okay, no more than 6 feet. And really, less than that is much, much better. Also, all of your hardware that is on your belts and your lines and your harnesses, all of these things are going to be forged or pressed steel, cadmium plated, and they are also going to be locking so they don't just fall off. So locking harnesses, locking hooks is very, very, very important. Make sure while you're putting before you use it, but while you're putting it on, make sure you do an inspection of your harness to make sure all the components are working. Make sure that in this case, you know, your clip works, that it locks. Make sure that this is a tensioning device, that works, it slides up and it grabs hold. In this case, make sure your harness is in good shape. It doesn't have any snags. It doesn't have any tears. It doesn't have any deformation. Make sure the buckles are all working. It's important. Make sure everything involved with those is in good shape. Safety nets, we'll see these, especially when workplaces are more than 25 feet above the ground. We really don't see these in residential construction. Where we see these is we see them occasionally in commercial construction like we see here, but we do see them a lot in things like bridge construction. So that's important to remember. Safety nets, essentially what their job is if you fall, you land on the net, and then you recover, you climb out of the net, and you go back to work. Now, sometimes you'll see nets will be strung on commercial buildings, and those are designed for catching things, tools, soda bottles, rivets, and anything that might fall from a high elevation and get caught in these nets, and at least, if not stopped completely, it's slowed down drastically. Because remember, a tape measure that falls from 15 stories, I don't care what hard hat you hit or you have on your head, when it hits, it's going to do some damage to your head. So nets need to extend 8 feet out beyond the edge of the work surface, and that is so, obviously when you fall, if you fall away from the building, you will fall into the net. It's very important that they're as close as under the work surface as practical, all right? Because you don't want to have a super free fall, all right? You're not a trapeze artist. So you want that net to be pretty close to where you're working. So if you fall, you're not free falling all that much. If you're working over water, because a lot of times folks will be working on doing bridges, or they're working on buildings, and some of those buildings may be close to water. And if you are close to water or working over water, it's important to make sure that you've got a buoyant work vest or some sort of life jacket. It needs to be U.S. Coast Guard approved so that if you do fall in the water, you can stay buoyant. Also have a ring buoy there so that, if you do fall in, you've got a way to throw it to somebody and tow them in. It's important to have life-saving skiff and some sort of life-saving ring or something to help bring that person back into shore and make sure that they're okay. So to summarize, we talked a bit about general provisions of the standard and the basic hazard category, as well as some of our hazard sources and some of the PPE that we might use. Now, one thing we've had a lot of questions about, which I'm going to talk a little bit about before we go here, and that is the use of PPE, specifically something like an N95 or some sort of filtering face piece. So just bear with me, and we're going to go to a live video. Now, one of the big things people ask about all the time is, how do I put a face piece on? How do I put a mask on? How do I actually use it? So that's what I wanted to talk to you a little bit about today. So I actually have some examples with me. So here I have 2 examples of N95 respirators. Now both of these are N95 respirators. This one has an exhalation valve, and this one does not. That's the only difference between these two. They're both exactly the same. One has an exhalation valve, one doesn't. This one with the exhalation valve, what that exhalation valve does is when you breathe out, it has a small butterfly valve inside of it that allows the hot air and moisture to leave when you breathe out. That way the mask itself doesn't get all gummy and wet on the inside. It lets the moisture out. This one, it does the same job, it just does not have that same valve, one-way valve in it that allows the moisture to escape. Now, what makes an N95 respirator an N95 respirator? And you can see right here, when we look on it, it has a NIOSH number, and it says right there N95. What does that mean exactly? Well, the N, there are three types of masks. There are N, P, and R series, and these all have to do with oil. So an N is not resistant to oil. An R is somewhat resistant to oil, and a P is strongly resistant to oil or oil proof. All right? So with that, we also have another category. So now we have the N. What does the 95 mean? Well, the 95 is the filtered particulate. So you have filters at least 95%, 99%, or 99.97, which is essentially 100%. In this case, this is an N95, so it's going to filter 95% of our airborne particles. So how does this work? Well, I'll show you. So we have the mask, and we're going to hold it in our hand just like this. Because remember, you don't want to put your hands on your face. You want to keep your hands clear of your face, so we don't want to handle anything other than the respirator on the outside. What I'll do is I bring this up to my face and put it over my face like this. Now in this case, I'll have to take my glasses off, but you can see I've made kind of a pseudo seal on my face like this. There are two straps. This one goes over the top, this one goes over the bottom. The first one I'll pull over is the bottom. You can see I have it around the back of my neck and under my ear. Ladies, if you have long hair, make sure you pull your ponytail or your long hair up and put it underneath so it's resting on the nape of your neck. The second strap goes across the top like this, and you can see it goes just above the ear and right around the widest part of my head. And now, the last part is I want to make sure that this nose bridge, see this metal bridge, is compressed so that it makes a good seal around my face. Now, how do I test that seal? That's one question everybody has. So I'll show you. Simply take your hands, cup them over the top, and try to breathe out. If I have air resistance there, that means I've got a good seal. It should resist coming out. If I can feel air coming out, say here at the top, I may need to readjust this bridge of my nose. And that's okay, you can do that. That's not a problem. But you need to make sure that you've got a good fit at the top and the bottom. To take it off, you simply reverse the process like this and pull it down from your face. Now, I have a second type of respirator, and this is a half mask respirator. It has valves very similar to the other one, where it has an exhalation valve that's a butterfly valve that pops out when I breathe out. And it also has valves with filters on the inside. And these screw on, and they have a cartridge, and that cartridge is actually made of N95 filtering material. So this is an N95 respirator. Now, how do I put this on? Well, this one's a bit more robust. So I'm going to reuse the black part of the mask, clean it, wash it, keep it clean, but I might have to change these filters as they become more clogged up. And say, if they're dust, they may get clogged up with, say, drywall dust, in which case I might have to change them more frequently. If I was wearing in something like a hospital setting where I'm dealing with patients or something, and so now I'm worried about germs and viruses, I'm going to change them, say, maybe every shift, every 6 hours, every 8 hours, and put a new one on. So how I put this mask on simply is I'm going to put it over my face, And you can see here the head harness fits on the back of my head. I make a good seal here, and I will pull the strap behind my head and lock the mask. To remove it, I simply pull it off. Okay, so that wraps up our discussion of N95 respirators. I'd like to thank you for tuning in today, and we have other webinars that we're going to be sharing as we go through, and I would like to remind you that you can find these on our website at ncdol.com or NC Department of Labor. That link still works. If you just put in North Carolina Department of Labor, it will take you right to our website, and you'll be able to find training, and you'll be able to sign up for live webinars on a number of different subjects, not just PPE and respirators and things like that. We actually cover a lot of different subjects, including things like steel erection, concrete and labor, introduction to OSHA, inspection process, a number of different things. In addition, we also offer webinars that, to your specific audience that you have there at work. We also offer training, and when things are back to normal again, we will actually go back to doing face-to-face training at your organization. Again, you can find out all about all of these things by going to labor.nc.gov. Thank you so much for your time today. I appreciate it, and I will be signing off. You have a great day, and I will talk to you later. Bye-bye.